5.7 is on what we call coordinate proof and congruence and overlapping triangles. So sometimes when we place things on a coordinate grid, there's a certain way that we can place them that's going to make things easier to find. Okay, so it says use graph paper to draw a triangle with legs of length 3 and 4 or 6 and 8. Cut out the triangle and then place it on another piece of graph paper to draw a coordinate plane. Okay, so I want all of you guys to think about how you can put a triangle on here, a right triangle, that has leg lengths of 3 and 4. Anybody have any suggestions? Yeah, Cam?
So legs, I think, don't you go up 3 and then you go across 4, and then you...
So up 3 and then over 1, 2, 3, 4, and then draw a point, is that what you're saying?
Yeah.
Okay, and then how do I draw the triangle then? I mean, I can draw a triangle. So if I'm starting here, I could draw it in here and here, right?
Oh, yeah.
I could draw it in here, I could draw it in here, I could draw it in here, I could draw it in here. So what is that point doing? So we need some kind of other point, right? 2 other points to create that triangle. So I like what Cam's saying. So what if you drew your triangle like that? Would that be pretty good? If I asked you to find the area of the triangle, could you find the area of the triangle?
Yes.
Yeah, so you could say, okay, my area of the triangle, my base is 4, my height is 3, 1/2 base times height gives me 6, exactly. So that would be one way that you could draw it. Would it be easy to put it on the coordinate plane like this and then find the area? No, that would be terrible, right? So you would have to how do I count 3 units in this direction? I don't know. So that's not the best way. Personally, I think the best way is to just draw it so that right angle is formed by the axes. I would do something like that where I have 4 and 3. Okay. So what we're going to be doing today is something called coordinate proof. So we're going to be trying to prove things when maybe we have points where if I say the base of a triangle is B, well, if the base was a length of B, what is this point right here then? In terms of B, what would I write? B comma 0. Do you guys see that? Yeah, you'd go over B, you'd go up 0. And what if my height was H? What would this point up here be? 0 comma H, exactly. And then I could, find the length. Maybe if I wanted to find the length of the hypotenuse, I could find the length of the hypotenuse in B's and H's with the Pythagorean theorem, right? Or with the distance formula. So there's things that we can do with what we call coordinate proof, where we just have generic letters in for lengths. Does this make sense? Okay, so number 2, so it says place a 3x5 unit rectangle on the coordinate plane. Okay, so you can put your 3x5 unit rectangle something like, well, that's not 5. But you could do something like this, but do we want to do something like that? No, because these points are all kind of weird points, right? They're not nice ones. What's the nicest way to put that rectangle on our coordinate plane? Where would I put it? First quadrant, second quadrant, third, fourth, all of them? What?
First
First quadrant. I would put 3 units up, 5 units out, right? And I'd have this rectangle there. And then I could label those points. So go ahead and label these 4 points with 3s and 5s and 0s, right? So our bottom left one is 0, 0. The bottom right one is 5, 0. The top right, what do we put there? Yeah, Cam?
5,
5, 3. We only went up 3. Yep. And then left?
0, 3.
0, 3. Perfect.
Redemption.
Yes, redemption. Yes. All right. Does that make sense? Okay. So it says a right triangle has leg lengths of 6 and 8. Place the triangle on the coordinate plane, label the vertices, and find the length of the hypotenuse using the distance formula. So we're going to put them on there. So let's say I say 6 and 8. It doesn't matter if you do 8 to the right or 8 up. So I'll do 8 up. 1, 2, 3, 4, 5, 6, 7, 8. And I'll do 6 over. And then I draw it in. Are you with me? So I draw this in, and I have 8 and I have 6. And then I can label those points. I can call it 0, 0. I can call it 6, 0. I can call this 0, 8. So then with the distance formula, I would say, oh, well, if I take these 2 points, my 6, 0 and my 0, 8, and I find the distance between them, do you guys remember the distance formula? X2 minus x1 squared, y2 minus y1 squared, Joseph, you with me? So we get 0 minus 6 squared plus 8 minus 0 squared. And we simplify that all out, and we end up getting 10. Because we'd have 36 plus 64 under there. And 36 plus 64 is 100. And the square root of 100 is 10. Everybody see that? Or, instead of using the distance formula, we could use the Pythagorean theorem. That's where the distance formula comes from. It comes from the Pythagorean theorem. Okay, and we get that by using these the coordinate proof. Because if I had called this 0, 0, x1, 0, and 0, y1 or something like that. Or not 0. I don't know, if I had shifted it over, I'd have x1, y1, x2, y2. You could come up with the distance formula from those points. Okay? All right, so number 4. So it says in the diagram, EGD is congruent to FGD. Find the coordinates of point G. Do not make assumptions from the picture. So, looking at it, I would probably guess that it's negative 2.5, 2.5. It probably is. But the hard part about geometry is pictures aren't always drawn to scale. So sometimes you have a picture and you're like, oh, it looks like it's going to be negative 2.5, 2.5. And sometimes it's not. So be really careful with doing that, okay? So in this case, we're trying to say that these triangles are congruent to each other. So if EG and FG, that means those two would be congruent, right? You see EG and FG? And then GD and GD, well, clearly that's congruent to itself. And then the last one is ED. So this length here, whoops, I should use 2 different markings there. So this length here and this length here are congruent. So we can mark all those things in because we knew we had congruent triangles. And we can mark the angles in as well, right? So you can do all your angle markings as well. So question, if I know that these two things are equal, right, that means this was what we call a segment bisector. We had a segment bisector. What do I call this point? The midpoint. Do you guys remember how to find the midpoint of a line, of a segment? Yeah, so the midpoint formula says that we take our 2 points and we find the average of our x's and we find the average of our y's. So we do that. My 2 points were 0, 5 and negative 5, 0. So I'm going to find the average of the x's, average of the y's. So I'm going to add them together. And then I'm going to have 5 plus 0 divided by 2. So I get negative 2.5, 2.5. I was lucky. All right, make sense? All right, would you be able to do that if it didn't have 0, 5, but instead it had things like B, H and A, C? Would you be able to find the midpoint in symbols? No, you don't think so? Average of x's, average of the y's. What would the average of the 2 x's be? A plus B divided by 2, right? That would work. So the midpoint of this one would be A plus B over 2. And then the y value of the midpoint would be what? Yeah, H plus C over 2. Does that make sense? Or C plus H over 2. This is what we're leading into, being able to use symbols off the graph. Does this make sense? Okay. Okay, so it says describe how you would prove, or write a plan to prove, is how the instructions will sometimes say it in the book, that OU bisects angle TOV if T is negative 3, 5, so sketch it out. Maya, sketch it out. So negative 3, 5. That's T. 0, 5. That's O. And V is 3, 5. Oh, that was U, sorry, in the middle. And then O was 0, 0. So if we want to prove that this angle, TOV, has been bisected by this segment, okay, so what that means is we're trying to prove that our angles down on the bottom, these 2 angles, are the same. Which is kind of hard. How do you find the angle, without using a protractor or something? How can we do that? So think about all the things that we've learned in this chapter. What's this chapter been all about? Tell me some random things we've learned in the chapter. Proofs. So what kind of proofs did we do? Things that involved paragraph proofs. CPCTC, that's a common word. What else? ASA, side angle side, right? SSA. No, not that one. That's a bad one, right? SSA. AAS, angle, angle, side. So there were 4. So we had side, 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 angle, 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 side. What's the 5th one?
The one that I said.
HL. So HL, there's 5. So could we do one of those? I don't know. We probably could. So once we get that those 2 triangles are congruent, do we see the 2 triangles? Do you even see 2 triangles in there? Draw it straight across, right? Once we can get those 2 triangles are congruent, then we can say, oh, every single part of them is congruent then. So let's think about ways that we can say the 2 triangles are congruent. What could we use? We could use side, 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 right? If we found all those distances. And a lot of those distances aren't hard. Like this one's 3. What's this distance, the red line? 5. And then this one's 3. Those are pretty easy, right? We can say that TU is 3, UV is 3, and UO is 3 or 5 just by counting. We don't have to do the distance formula or anything there because they were straight up and down or right and left, right? So we have at least side and side. So we have that TU is congruent to UV. Maybe I should say it in another way. Maybe I should say TU and VU. I'll be very precise. VU. And then I have that OU is congruent to itself. Right? Reflexive property. Do we have any angles though? Because I have 2 sides now. So I could go with side, 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 but what am I going to need to find if I do that? Yeah, I need to find the length of this hypotenuse. So I could do that. Maybe find this length of the hypotenuse. Or, what else could I do? Could I find 2 angles are the same? What 2 angles have to be the same? Look in here. Those 2 angles right there. Don't those both have to be right angles? Okay, you can tell from the picture they're right angles, right? Why are they right angles? Because we know that TV is perpendicular to OU, right? Really from the picture. But what else could I do? Because the slope, their slopes are opposite reciprocals. Or their slopes are, one of the slopes is, what's the slope of a horizontal line? Do you guys remember? 0. What's the slope of a vertical line? Undefined, exactly. So because the slope of TV is 0, and the slope of OU is undefined. Okay, I'm just writing that on there because sometimes we don't have them like perfectly up and down, like perfectly like horizontal and vertical. Sometimes we have these triangles that are rotated. And if you want to show that you have a 90-degree angle, you would have to find the slope of this line. So let's say it was like 5/6. What would the slope of this line have to be? Yeah, -6/5. They'd have to be opposite reciprocals. Do you guys remember that? Okay. So sometimes we have to show that with the slopes in order to get perpendicular. So that means that angle TUO is congruent to angle VUO because right angles are congruent, right? So all right angles are congruent. So then we can say our triangles are congruent. And what did I use to say the triangles are congruent? Not yet. So she's saying the next thing is going to be CPCTC. We used side angle side. Do you guys see how that's side angle side? We have the side, we have the 90-degree angle, and another side. Side, 90-degree angles, another side. Not really HL, because I didn't have the hypotenuse in a leg, right? I could get that hypotenuse by doing Pythagorean theorem. But in this case, I would just call that side angle side. So then we can say, well, that means that TOV is congruent to angle, not TOV, TOU. I'm getting these U's and V's confused. TOU is congruent to what? VOU by CPCTC. Okay, and then we're good. So that's our like plan for a proof. So there are many ways to write proofs. So sometimes we do like paragraph proofs, that's just kind of listing it out like I did there. Some people, you know, are very precise and write full sentences with their paragraphs. We probably should, but I'm lazy. And then some people will do statements and reasons, which we kind of did a little bit there. We didn't set it up with the statements and reasons. And then some people do what we call flow proofs. Have you guys seen those in your book? Yeah, I think you guys have one on your homework. So it's like this leads to this, which leads to this, which leads to this. Okay, so it says sometimes you're not going to have numbers in your proof. So you're only going to have variables. So it says use a paragraph proof to show that triangle OPQ is congruent to QRO. Okay, so let's first find those triangles. So OPQ, okay, that's this triangle right here, is congruent to QRO. That's this triangle right here. Right? You don't just shade it in. I'm just shading it in so you can see it. So we want to prove that those are congruent to each other. So are there things that we can get? Like, for instance, this distance here. A lot of people start counting. They're like, I'm going to count these little squares. 1, 2, 3, 4, 5, 6. What's wrong with that? Why can I not just count the squares? I don't know how big those squares are, right? Are they all 1 by 1? It goes up to something that I don't know. It says H. Is it H? I think it's H. Yeah. Or N. Actually, I think it's N. I just have bad handwriting, so make that look more like an N. I still made it look like an H. So an N. So what distance is that? I go from a height of 0 up to a height of N, right? So that distance is N. What's this distance over here? Look at it. We go from a height of K plus N to K. If I do K plus N, or minus K, dang it, what do I get? N. Do you guys understand that? Yeah. Just because it's letters, don't let it freak you out. But these distances are harder, like this one and this one. I don't know if I want to do the distance there. That seems a little bit tricky. Okay? But I could find it. I could do the distance. How would you do it? Use the distance formula, right? So if I wanted the distance formula between 0, 0 and HK, it's going to be hard, but it's going to look like this. It's going to look like H minus 0 squared plus K minus 0 squared, which gives me H squared plus K squared. I can leave it like that. A lot of people think you can just take the square root of each thing. Think about that with numbers. If I have 3 squared plus 4 squared, what is 3 squared plus 4 squared? 9 plus 16. So when I take the square root of 25 is 5. Can you just say the square root of 3 squared plus 4 squared is 3 plus 4? No, because that's not 5. That's 7, right? Does it make sense? So you can't just bring the square root into both of those. All right, so what if I had the points, this one and this one? So I have 0, comma, n, and I have h, comma, k plus n. Could I also do the distance formula for this? Yeah, don't let the letters scare you. You can do this. So it's going to be h minus 0 squared plus k plus n minus n squared. Do we get the same thing? Yeah. So I get the square root of h squared plus k squared. So those are congruent to each other. We can do these markings then. We can be like, oh, those are the same. Just like the ends were the same from before. So right now we have two sides. Is this last side congruent to itself? Yeah, the last side's congruent to itself by the reflexive property. So then we can say, okay, they're congruent by side, side, side. That is not the only way you can do this proof. You can do coordinate proofs in a variety of ways, just like you can do other proofs in a variety of ways. What if I had decided I wanted to use the slope? and I had gotten that this slope was the same as this slope. Then if I have a transversal, right, I could say, well, hang on, maybe that's not what I want. Let me do the other slopes. I'm drawing it wrong. Because I want my z shape, right? So this slope and this slope of that transversal. Could I say that this angle and this angle are the same? Do you guys see it? Yeah, alternate interior angles. How would I get these slopes are parallel? Well, these ones are both vertical slopes. They're both undefined. Does that make sense? So if I have two undefined slopes, they're parallel lines. Do you guys see what I'm saying? There's lots of ways you could do this. If you wanted to get the top and the bottom ones parallel, then you would just count, like rise over run. But it's a little weird counting. You're not counting boxes. You're saying I went up N. No, I went up K and I went over H. Right, you could do it that way as well. Does this make sense? Do you guys get it? All right, so let's move on to the overlapping triangles. So that's the other part of this section. So it says sometimes you have overlapping triangles, so find all of the missing angles. Oh, I think I'm missing something in number 3, maybe. We'll see. Okay, so here's our overlapping triangles. This one, which I can redraw over here. It has angles 89, 59, and something. How do I find the something? Yeah, Cam?
Those two added together minus 180.
Yep, so 89 plus 59 is 148. Subtract from 180, so I get 32. But we have another triangle. We have this one, and we have this one, or this triangle in red. So let's draw that one in red. And sometimes you're going to have to do this on your paper. It helps. So we have 35 and we have 89. And if I subtract from 180, I got this one as 56. Are the triangles congruent to each other? No. Even if they have the same angles, would they necessarily be congruent? I don't know. We don't know if they have the same side lengths, right? So we don't know. All right, so number 3. So find FCA if you know that F and D, oh, that's how I fixed it. So F and D are congruent to each other. So let's put like marks there. So again, we're trying to separate these triangles. We're trying to look at them separately. So let's highlight this one in red. So maybe you guys can use highlighters on your homework if you're doing this. And we knew that we had a certain angle. We had 63, and we don't know that one. And then we have another angle, another one that's in blue. And we at least know that it has a 90-degree angle, but we don't know that one. Do we know anything else in the blue one? Yeah, what do you have, Sophia?
Angle
EBD.
33.
Yep, exactly. She says this is 33. Do we agree? Max, you with me? So this is 33 here. I agree, because they had a linear pair, right? They made a line. This was a linear pair. Okay, so then if I have my 90-degree angle and 33, what's the one that had 2 marks then? Add them up, 90 plus 33, 123, subtract from 180. I think it's 57. Do you guys agree? So then that means this other one is also 57. So can we get the question mark then? Yeah. So 57 plus 63 is 120. So what's this one? 60 degrees, right? Does that make sense? Do you guys get how we do overlapping triangles? All right. Okay, so number 4, so write a statements and reasons proof. So this is a tough one. So I'm not going to formally write out the statements and reasons, but let's talk through this together. I'm going to make it a little bit bigger so we can see it. It's always scary when your teacher says this is a tough one next to a proof. All right, so let's mark in the things we have. So we know that BA is perpendicular to AD, and we know CD is perpendicular to DA. Okay, so I think it's safe to say that our angles A and D are congruent to each other. They're both right angles. How about AF? So it says AF, this distance, is congruent to DE, and BE is congruent to CF. Okay, how do you think we're going to get triangle ABE is congruent to triangle DCF? Any ideas? hard. We have to use this little tiny piece right here, this FE. Do you think we could say that AE and FD are congruent? Why? You did this a long time ago. There's a certain postulate.
Segment addition.
It's segment addition postulate. Do you guys see how we can do segment addition postulate? I can say AF plus FE equals the whole thing AE. And I can say DE plus FE or EF is the whole thing DF. If I knew those middle pieces were congruent, the smaller pieces, like the smaller pieces and the medium pieces were congruent, then I can say their total lengths are congruent, right? Does that make sense? Okay, so that means we have a triangle where we have this marking and this marking in a right angle. And then we have another triangle where we have this marking, nope. This marking, and a right angle. It looks like angle side side, which is a bad one, right? What's the one form of angle side side that works? Hypotenuse leg, is that what we have? Do we have a hypotenuse marked and a leg marked? Yeah, so it'd be hypotenuse leg in the end. Okay, so I didn't do the full proof, but do you guys understand what we would do to get the proof? Yeah. Oops. All right, do I have one more? I feel like I have one more. How do I go to the next page? There we go. So write a statements and reasons proof. So same idea. So let's just kind of talk through it. We don't have to do the full proof, but think about it. So TM and TN are congruent. TRS, this angle right here, and TSR, hang on, TRS, I did the wrong one, didn't I? TRS, this whole angle, and TSR, this whole angle, are congruent. Prove that RTN and STM are congruent to each other. Okay, that's a hard one. Okay, there's a lot going on there. These are really hard proofs. They won't be this hard on your test, no worries. Okay, so let's look at the whole picture, like all together. We had these two angles are marked. What kind of triangle is that? Isosceles, right? Isosceles triangle. And with isosceles triangles, the base angles are congruent, means those two legs are congruent, right? So we could say that TR is congruent to TS. This whole length here and this whole length here. Do you guys agree? All right, so because of that, well, I guess that's okay. So what else do we need? Okay, if you look at these triangles separately, so I have T, N, and R, and I have T, S, and M. We just showed that those long ones, the TR and TS, were the same. But we need other things. What about these two angles? Why are they the same? These are so quiet today. It's like reflexive property, right? That's the same angle up there. Right? Do you guys see? It's a shared angle. So we have an angle and a side. So if we can get this side on this side and this side, we're good. Do we already have that? Yeah, we already have that TM and TN are congruent, right? So can we prove the triangles are congruent? Yeah, by side, angle, side. Okay, does that make sense? Okay.